Welcome to this tutorial. My name is Stefan Dahinden and today I'm going to show you how to perform an additive phase noise measurement with the APPH20G or APPH6040. I have already started up the APPH GUI and I'm also connected to an APPH20G that is standing right beside me. So to start, we're going to switch to the Additive Phase Noise Measurement tab over here. So let's go shortly through the measurement setup. I'm pressing this question mark button to see a schematic of the measurement that we're going to perform. And you can see, besides the amplifier, which is our DUT, we also need an oscillator with a good phase noise characteristics, especially if we are using single channel measurement. I'm using an absent generator that is outputting a carrier frequency of 2 GHz at 16 dBm. We're also going to need a power splitter as well as a phase shifter. The phase shifter needs to cover a 360-degree phase shift of the carrier frequency of the oscillator. Okay, let's go through the options. First, we already know those options. They are the same as in the absolute phase noise tab. We have the carrier frequency and the detected power level. We have the offset range of the measurement. We're going to use 10 Hz to 50 MHz. And we also can set the number of correlations. I already preset that to 10. Now let's go back to the schematic. We always need to make sure that the drive level of the reference input and the DUT input are high enough, meaning 10 dBm or higher. Usually we can already achieve that with the measurement setup itself by setting the power level of our oscillator. Sometimes we need to adjust a little bit. For that we can attenuate or amplify the DUT signal over here. And we can also amplify the reference signal over here by enabling an amplifier. We can also select between a one-channel measurement and a two-channel measurement. Let's shortly select the two-channel measurement. You can see we would need an additional phase shifter and an additional power splitter for the two-channel measurement. Today I'm going to use a single-channel measurement. We can also select between a manual phase shifter, which we're going to use today, or an analog tunable phase shifter. So you can see now the phase shifter is tuned by the tune output of the reference. And we can also set the tune range that we want to use. Let's go back to manual. And let's start with the measurement. First of all, we need to determine the phase detector constant. We can do that by pressing the measure button and manually shifting our phase over 360 degrees. So let's do that shortly. An algorithm automatically determines the phase detector constant while we are doing this. So you can see the phase detector constant is shown here, and we can press confirm. The next step is to achieve phase quadrature. For this we need to minimize the phase error to 0. You can already see if I adjust my phase, I can change the phase error. And we need to get it down to 0. that's good enough. Let's confirm again. And now we're ready to start the measurement. So we can just click on this measure button here and wait for the measurement. So you can already see the first few iterations of the measurement. Let's just wait until it's over. Okay, so the measurement is completed. Let's add it to our traces. Now, we always need to look at this measurement with respect to the measurement setup and the noise floor of the instrument. So we can measure the noise floor of the instrument by removing the DOT and just connecting those two cables with each other. And then we can perform the same measurement that we just did. I already did that before the tutorial started. So let's look at the noise floor. You can see that over around 200 kHz, the measurement is dominated by the instrument's noise floor. And below 200 kHz, we can directly see the amplifier's phase noise. If we would want to also measure the phase noise of the amplifier over 200 kHz, we would need to switch to a two-channel correlation. Okay, so we're finished with the measurement. You see it was very easy to measure an additive phase noise, to perform an additive phase noise measurement with the APPH20G or 6040. I thank you for listening and goodbye.